Very good evening, everyone. Today we will be seeing the tutorial 1 for BT39 course. So let me present the screen first. I hope the screen is visible. So we will be seeing almost 10 questions from week 1. This is tutorial session. So we'll just get into the questions first. Which options describe hybridomas? So option A is given as antibody producing cells in the body, cancerous cells in the body, a fusion of antibody producing cells and cancerous cells, and option D is cells producing low cost insulin. So we'll just check like what is hybridomas first. So for to understand hybridoma, we'll just see the technique, hybridoma technology. The antigen is injected into the mice body to elicit the immune response, and the plasma cells from the splenocytes are being collected. With this, the myeloma will be fused. So the reason why myeloma is fused with the plasma cells is that the plasma cells are short lived, whereas myeloma are cancerous cells which will increase the lifetime of the cells rapidly. So by fusing plasma cells and the myeloma cells, we'll get the hybridomas, which will be cultured to screen like which are the fused cells and not the unfused plasma cells, unfused myeloma cells, and everything. So based on this, what we are understanding is that hybridomas are a fusion of plasma cells. Plasma cells are nothing but what? B lymphocytes will be differentiated into plasma cells, and plasma cells will be giving up the antibodies. So these are antibody producing cells only. So hybridomas are nothing but a fusion of antibody producing cells and the cancerous cells. So option C is the right answer. Moving on to the second question, which of the following products are commercially produced using bioreactors? So we'll just check on like each and every, yeah, we'll just check on each and every option. So insulin, yes, insulin, there is a bacteria biotechnological way of producing insulin. So we can say it is being like produced using bioreactors. Whereas like, do you think milk is being produced using bioreactors? So we can say the other way around. So milk is not being produced using bioreactor, but there are milk proteins which are being produced by bioreactor by many dairy industries. Like, so we can say like if it's milk protein, we can say S. Okay. Whereas when it comes to petrol, no, it is not being produced through bioreactors. And bio oil, you can call it as like triacyl glycerol. Triacyl glycerol is a bio oil. So these are produced using bioreactors. Okay. So option A is not the right answer. So option B, if you see, yes, insulin is being produced, and MAB is like MAPS. We call it as like monoclonal antibodies. These are being produced by bioreactors in a large scale. And as antibiotics, we know like the very well known antibiotic is penicillin, which is being produced by Penicillium notatum. Yes, it is being produced using bioreactor. And as Sir has already discussed in the course, biomass itself can be a product sometimes. Example can be spirulina and many other like algal products as well. So yes, biomass itself is a product here. So option B has all the four options that are right. Okay, we'll just check on to B as well, C and D as well. Bread is not being produced using bioreactor. Milk proteins can be produced using bioreactor. S, bio oil, and curdling proteins like casein and all these things can be produced using bioreactor, but not curd. Okay. So moving on to option D, yes, MAPS being produced, insulin being produced, not crude diesel. If it's biodiesel, yes, the answer is right, and yes, bio oil. So out of these four, what is the right option? B is the right option. Moving on to question 3. The media used for a bioprocess is contaminated with single cells with similar thermal response characteristics. It has been observed that by maintaining the media at 60 degrees Celsius for 25 minutes, 85% of the cells become non-viable. Determine the decimal reduction time. Choose the answer closest to your calculated answer. So as Sir has already discussed, problem solving is a skill. Like we have to first of all like write down what are all the given, what are the data that has been given, and what we have to find, and all these things we'll just see at first. Okay. So what is decimal reduction point? That's what we are going to find it in this problem, right? So decimal reduction point is the time taken for a tenfold reduction in the viable cell concentration at a given temperature. Okay. So here the formula is D is equal to 2.303 divided by Kd, where Kd is the thermal death constant. So what are all the data that has been given? So it's a single cell. This is very, very important. It's a single, the media is being contaminated by single cell, and it has been given that at 60 degrees Celsius for 25 minutes. So you have to write it down in terms of seconds only. The viable cell concentration goes from 100%, that is XP naught initial viable concentration, to 15%, which is the remaining viable cell that is being present at the end of 25 minutes. So here the fold reduction will be 100 divided by 15, which will be 6.6 fold reduction has happened. Okay. So what we have to find here, we have to find actually we have to find the thermal, just a minute, yeah. So actually we have to find D, right? That is the decimal reduction point. But to calculate D, we need thermal death constant as well. We have to know like what is thermal death constant. So to find Kd, this is the formula. T is equal to 2.303 divided by Kd log to the base 10 xv naught divided by xv. By as we know the xv naught by xv and we know the time taken, we are just substituting everything to find Kd, which is equal to 1.26 into 10 power minus 3 second inverse. So by substituting the Kd that we have found in the decimal reduction point formula, we are getting almost 30.35 minutes. So the option that is nearer to this is option C. Okay. Moving on to question 4. Identify the mass balance equation for the microbial cells in a bioreactor under batch operation. Here Ri denotes rate of input of cells, R0 denotes the rate of output of cells, Rg is the rate of generation of cells, Rd is the rate of death of cells or rate of consumption we can say, and here the rate of accumulation of cells is denoted by dA by dt. So we'll just see like what happens in batch operation. So the overall mass balance for like a process is Ri minus R0 plus Rg minus Rd is equal to the accumulation that has been given here. So we have just used the designations that has been given in the problem statement. So what we know about batch fermentation is that it's very important to note here, it's going to be a batch operation. So like in batch, what happens is that we will like sterilize the reactor with the media components, and we will inoculate the cells into the uh, reactor. And once the batch operation starts, we will just harvest when once like the overall fermentation is over only. There won't be any input as well as there won't be any output during the batch operation. So what does this mean? There will not be any rate of input of cells and rate of output of cells during batch operation. So by giving these two 0, what happens here? Rg minus Rd is equal to dA by dt. So here the right option will be option C. Okay. Moving on to question 5. Match the following important components of bioprocessing. So here recombinant E. coli, for which what can be the answer? It's an inoculum, right? The cells are going to produce some recombinant proteins or whatever it is. It's a recombinant E. coli. So for that, it is going to be inoculum. Whereas glucose is a carbon source, hence it is a substrate only. Whereas uh, based on whatever is being given here, amylase has to break the like bonds, like alpha 1 comma 4 bonds, I guess. So this is going to be, this is an enzyme that is being produced commercially as well. So here this is going to be the product. So what is it here? The recombinant E. coli is the inoculum, and glucose is the substrate that is being going to be utilized by the cells, and the product that is going to be produced by the cells is amylase. So the answer here is option B. Okay. Moving on to question 6. The main factors to be optimized while designing a thermal sterilization process are. So we have to be very careful about the questions that has been that are being asked. here it's very well written, it's main factors. So even if we tend to choose only one option also, we will not get like the complete marks. So it's main factors. So the options that are being given here are initial pH of the medium, time of exposure, DO, and temperature. So to understand this, we have to see the thermal death rate curve. So here what is being shown here is that N by N naught, which is like viable cell concentration at that minute divided by the viable cell concentration at the initial time point across different time points. Okay, so when they change temperature like 105 degrees Celsius for almost 25 minutes and 121 degrees Celsius for almost like 2 minutes. So all these are completely dependent on what? The temperature as well as time, right? So these two are going to determine how much sterilization is going to happen, how much amount of cells that are being like left out as viable at the end of sterilization, right? So what can be the answer for the question based on the thermal death curve? So the thermal sterilization process is being dependent on the temperature as well as the time of exposure. Okay, whereas initial pH of the medium is not going to matter at all. Anyway, the sterilization going to happen even if your pH of the medium is going to be 2 or even 10 as well. And the DO here, when we are talking about any fermentation process, their DO is very important. If your cells are aerobic or like even it can be facultative anaerobe, based on that the DO will be very very important. But as we are going to sterilize the media, so which means like we are going to kill the cells. So for that the dissolved oxygen concentration doesn't matter at all. Moving to question 7, identify the type of bioreactor where aeration and agitation is being brought about by pumped air alone. So the options that are being given are stir tank bioreactor, airlift bioreactor, packed bed bioreactor, solid state bioreactor. So we'll just see each one. So if you take stir tank bioreactor, so here the aeration is being given by the sparger and the agitation is being brought about by the agitator or the impeller. So for both there are like two separate parts that are being fixed in the bioreactor. So A is not the right option. Moving on to B, airlift bioreactor. If you see the sparger is giving up the air that will be almost taking up the cells and then almost it will be coming through the other column like that has been placed. Okay, so with this what we can find, like airlift bioreactors are known to provide air for both aeration as well as agitation. Here aeration is the one that is going to help you to mix up the media as well, and that is what is going to give aeration to the cells as well. So the answer is airlift bioreactor. Still we'll just take out like what about packed bed bioreactor as well as solid state bioreactor. So in packed bed bioreactor, if you see the aeration is being given, but your cells or your enzymes that are being immobilized and kept in your packed bed bioreactor, the aeration is going to just give air to the cells and there will not be any mixing of cells here due to the aeration. Okay, and similarly for solid state bioreactor, in solid state bioreactor, your solid substrate will be kept on the trays and aeration will be there for the organism to perform fermentation, but the aeration is not going to do agitation. So out of these four, the answer is going to be airlift bioreactor. Moving on to question 8. Dr. A is going to do a microbial experiment in a laminar hood flow. Which of the following can she use to sterilize the hood? So it has like the options that are being given are syringe filtration, UV lamp, 70% ethanol, and autoclaving. So as we are talking about laminar airflow hood, autoclaving is not the right option because we really can't go and put the laugh inside an autoclave for sterilization. And obviously, like it's not related to syringe filtration in any way. So the option that are being left out are UV lamp as well as 70% ethanol. So this is the laminar airflow hood. So if you see, like both the options are right, we will be using UV lamp to sterilize the hood before starting any like experiment, and 70% ethanol, which is a disinfectant, is being like wiped this, which is being used to wipe the surface of the laminar airflow. So both options are right. So we'll just see like how these are being useful. So UV lamp, if you see UVC, which covers the wavelength of almost 200 to 280 nanometer, it's known to be highly effective in damaging the DNA because it forms thymine dimers which are being present like adjacent. If a thymine is present like somewhere, the adjacent nucleotide will be like mutated and the thymine dimers will be formed, which interferes in the replication process. So the replication will be halted for so long. That is, the cell division is being like halted for so long. If the prolonged cell arrest happens, it will lead for cell death only. So this is how UV lamp helps in sterilizing the wound. And we know that 70% ethanol is known for protein denaturation as well as lipid dissolution, because we have our outermost layer as like your what is this called, phospholipid bilayer, which has lipids. So it will be helpful in dissolving the lipids as well. And dehydration, obviously alcohol dehydrates, will try to pull out the like water from inside the cell, which will end up in shrinkage of the cells, and that's how the cells are dying here. So moving on to question 9, match the following parts of bioreactor with their purpose. So sparger, deosensor, and impeller, these three are being given here. So we'll just look at the diagram of still tank bioreactor. So here first one is sparger. So sparger is being used for aeration, right? Through the pores that are present in the sparger, the air will enter the bioreactor. So the answer for sparger is going to be aeration. So for DO sensor, as the name mentions, that it is going to sense the dissolved oxygen concentration that is present in the fermentation broth or the media that you are going to use. So here it is going to detect your oxygen level. And moving to third one, which is impeller. Impeller is going to help you for mixing the cells equally, like without forming any dead zone in the bioreactor. So the option for this will be agitation. So the right answer is B. Moving on to the last question. Dr. X runs a bioreactor experiment and found that his process produces some toxic byproducts, which are affecting cells' viability when accumulated. Which of the following mode of bioprocess is suitable to solve this problem? So the option is uh, A. Batch mode alone, B. Continuous mode alone, C. Fed batch mode alone, and D. Both fed batch as well as continuous mode. So at first, the answer that is going to strike us will be continuous mode only, because we know what is continuous operation, where you will be continuously feeding your like media as well, and in the meanwhile we will be removing the fermentation broth from the media, and the will be separated. Your cells will be separated through a membrane filter and it will be pumped back to the reactor, whereas your media will be taken for purification, right? So this is very evident that if any toxic byproducts are there, the continuous mode of operation will be right, because your fermentation broth, if it's an extracellular product, obviously, so the product that is being present in the fermentation broth is going to affect the cell's viability. Say for example, any lactic acid or any product like that is going to, if lactic acid is being produced by the cells, what happens? It's an acid, so the pH of the media reduces very drastically. After a certain concentration, the lactic acid will be affecting the cell's viability. Say for example, 10 gram per liter of lactic acid. So we can make sure like the fermentation broth is being removed, where the cells are being pumped back to the reactor to avoid the cell loss or something, whereas the fermentation broth which are being removed will be taken for further purification, so that we will avoid accumulation of the lactic acid in the fermentation broth. So the continuous mode of operation is one of the right answers. And S, the fed batch mode of operation, is also being used to avoid the toxic byproduct formation. So what happens in fed batch? So we will be feeding our once our batch is over, we'll be feeding our substrate at a concentration throughout our fermentation process, right? During fed batch fermentation. So this is to avoid Crabtree effect. So what is Crabtree effect? Like here what is going to happen is that if we are like almost increasing the concentration of the substrate to almost like 200 or 300 gram per liter during batch fermentation, whatever the like substrate that is being available, it will be like used for all the other metabolic activities as well. Say for example, your intended byproduct product is going to produce product X. Okay, but as the substrate is available in like multiple like it's available surplus, all the other byproduct metabolic pathways will also be activated, which will lead to your byproduct formation, and hence the yield of your product will be reduced. Okay, so whatever the byproducts that are present, that will be affecting the cell's viability as well. So to avoid this, only fed batch fermentation will be used. So once our batch process is over, we will be feeding substrate at a very minimal concentration, so that the maintenance activity as well as the product formation will be mainly focused, rather than diverting the flux for other byproduct formation also. So this can be explained with Crabtree effect. Say for example, it was given that um, if so much amount of glucose is being available, so the glycolysis pathway will be what to say it will be occurring throughout by utilizing whatever the glucose that is available in the media. But what happens is that your TCA cycle as well as your ETC cycle can accommodate whatever the enzymes are there, can accommodate only a certain flux from your glycolysis pathway. So what happens is that the acetyl CoA will be diverted for lactic acid as well as other byproduct formation due to the enzyme unavailability in the TCA cycle as well as your ETC pathway. So because of this only your toxic byproduct formation happens. Okay, so here that we have to about fed batch fermentation, I have used this phenomena called the mechanism called Crabtree effect, which you can check it out as well. So is there any questions? Thank you so much.